Hello math learners, check this out. 7 trillion. This is ones, tens, hundreds, the thousands, the million, the billion, and the trillion. 7 trillion. This is 2 billion and 300 million. This is 65. So difficult, right? These are very big numbers and these are very small numbers. Now, is there any way that we could be writing this in a simplest way? For sure, there is. And that is our topic for today, my dear math learners. Today's lesson, we're going to discuss scientific notation. And if you don't have any idea about this topic, then tune in and finish this video. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for the grade 7 mathematics, which is all about scientific notation. Now, the question is, what is a scientific notation? Scientific notation is another way of writing numbers. What we see in our daily lives are what we call the standard notation, like this. But if we are dealing about bigger number or smaller numbers, basically, the scientific notation will give you a very handy job to do it. The question is, how do we write scientific notations? Okay, scientific notation has its parts. The first part is what we call the coefficient. So example, we have 2.65. So that is the coefficient. And then this will be preceded by a multiplication sign and then the powers of 10. So example, 10 to the 8th power. Okay, so this is read as 2.65 times 10 to the 8th power. Or 2 and 65 hundredths times 10 to the 8th power. Now, the technique here is very simple, my dear math learners. The rule is that you need to write your coefficient such that this value should be from either 1 up to less than 10. Meaning, it should not come up to 10, but it's just less than 10. Meaning, 9 point something. Okay? So, 1 point something to 9 point something. Okay? So, that is the proper way of writing the coefficient. While your exponent, that is 10 to the power of 8, now, this times 10 will always be there, but your exponent will be depending on how many movement you made from your original decimal point. Okay, so what am I talking about? Let's consider these given examples. We have 7 trillion, right? Now, where do you think is the decimal point? Okay, it is here, right? On the end of the whole figure. So that is 7 trillion and the decimal point is here. So what we need to do is we will be going to the point in which this will be bigger than 1 but less than 10. So your decimal point, since this is 7 trillion, this will be moving going here. Okay? This is the place where it will end. Why? Because if you place the decimal value before the 7, it will become 0.7, which is less than 1. If you end up in 70, that is bigger than 10. So it must be after 7. Okay? So the significant value here is very, very crucial, my dear math learners. Since in this given, the significant value is only 1 and that is 7. Okay? So therefore, we need to put our decimal point from here going to this part. So how do we write our scientific notations now? So we just write the 7, okay? And then times 10 to the power of, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so that is times 10 to the 12th power. So this is the scientific notation of the 7 trillion. So now, how about 2 billion and 300 million. Okay, so 2 billion and 300 million, the decimal point is still here, right? Okay, so the significant figure of this given number is the 2 and the 3. Remember that the significant value or the significant figures in a given number is basically the non-zeros. Okay? So, that is 23. So, there are 2. So, we just put 23. However, the decimal point should be between 2 and 3 so that it will not violate the rule, which is from 1 up to 10. Okay, so that is 2.3 times 10. So how many movement is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that is 9, 10 to the 9th power. Easy, right? Now, how about if we are considering a very small number? So how do we read this one? So this is 65. Okay, let's try. That is tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 100 okay, I already have lost in my calculation, but our aim here is putting this into a scientific notation, and what we need to do here is we move our decimal point to here, to 6.5, okay, so that it will not violate the rule of 1 up to less than 10. So that is 6.5 times 10. So how many movement is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the 11th power. But that is negative. Now, you may be asking me, Sir Ash, why is it negative? Okay, this is the rule, my dear math learners. If your decimal point is moving to the left, okay? It is moving to the left. From its original, it moves to the left. The exponent of your scientific notation will get bigger. Okay? It will get bigger. So that is positive. However, if your decimal point will move like this to the right side of the standard notation, then it will become lesser, meaning that is negative. Okay? So, how many movement is that? That will become a number with a negative sign. Okay? So, let's consider other examples for you to have more concrete understanding about this topic. Okay, math learners, we have here two sets of example. One set is all about standard notations, and the other set is in the scientific notation. Now, these examples will teach you how to convert from standard to scientific and from scientific to standard. Okay, so this is read as 720,000. Okay, so how do we write this in scientific notation? So 720,000, that is 7.2. Okay, times 10. So this is our answers. Okay, so that is 7.2. So our decimal point is from here. So we need to be arriving in this part. So that is 1, 2, 3, 4, 5. So that is to the 5th power. Easy, right? Now, going here, we have 1,109. Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billion. So, 1,109, 10 billions. Okay? So, how do we write this one? We need that our decimal point will be here. Okay, this part. Because if it is here, that will become 11. That violates our rule. So much more if it is here or here. And if it is also here, it violates that our value will become less than 1. Okay, so it must be 1 point something. Okay, so that is 1.109 times 10 to the negative, okay, 1, 2, 3, 4, 5, 6, 7 to the negative 7. So remember that this example, if we are dealing with decimal points, we are dealing with negative exponents. And if we have a whole number, we are dealing with positive exponents. Okay? So this is 91,600,000,000. So, as we can see here, our decimal point is in this place, right? So we need to put it here after 9. So that is 9.16 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, to the power of 10. Easy, right? So now, let us go to our next example, which is this one. How do we write scientific notation into standard notation? It is very easy, my dear math learners. Why? Because if you are dealing with positive exponents, then you move your exponents to the right. But if you are dealing with negative exponents, you just need to move your decimal points to the left. Okay, so how do we do this, my dear math learners? So this is the answer. So first, you just write the significant figure, okay? So this is 8 places, right? That is to the power of 8. So if this is your exponent, you just move 8 places. So that is 1, 2, 3. How many more movement? That is 5 more movements to the right, right? So you just add 5 zeros. And that will be your final answer. That is 131,300,000. So the decimal point is already here. Easy, right? Now, let us go to the second example. We have 6.589 times 10 to the negative 7th power. So basically, since this is negative, so you just write it here, 6589. Okay? So your decimal is here. It moves 1, right? We will be moving to the left. Okay? So, I already moved 1 here. Okay? How many more movements? 6. Okay, so that is 1, 2, 3, 4, 5, and 6. Then I put my decimal point and then put another 0 there. And this will be my standard notation for 6.589 times 10 to the negative 7th power. Easy, right? Now, let us go to the last example. We have 1.8 times 10 to the 6. So that is 18. My decimal point is here, right? So I move 1. How many more movement? That is 5 more because I already moved 1. It needs to be 6. So therefore, I just need to add 5 zeros in the right side. Okay. And my decimal point will be here. And that will be read as 1.8 million or 1,800,000. Okay? And that is how you write scientific notation to standard notation and standard notation to scientific notation. If you are dealing with bigger numbers and smaller numbers, this topic would be very handy for you. Now, this is the time that I will challenge you whether you have understood our topic for today, and here it is. Okay, math learners, I hope you have a wonderful time about our topic for today. This is still your free access math teacher Ash. And if you do have questions about our topic for today and any other topics about mathematics, don't hesitate to put your comments or your inquiries in our comment section below. Thank you for subscribing and giving a like in our videos. Hope you can share this to your fellow friends, classmates, and even to your students if you are a teacher or you are a parent that are teaching your students at home. Always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.